Welcome, ladies and gentlemen, to the India Reach series, Aerospace, Defence and Security Market Trends. My name is Chris Covage. I'm the Executive Editor and Director for My Security Media, and we're in partnership with the Aerospace and Defence Consultants Association of India and our partner and my co-host there in Delhi, Raman Sapori. Raman, thanks for joining us. Episode number 7.
Thank you, Chris.
Thank you very much. And we have another esteemed panel as we do week to week. As I just mentioned, episode 7, we're going to be looking at 3D printing technology applications and advancements. We have a panel in Mumbai, Delhi, and we've just been joined by Dr. Chandra in Bangalore, and obviously I'm based in Sydney. The concept of these webinar series are to look for opportunities for Australia and the ASEAN region, and obviously in the Indian market also. Dr. Chandra there in Bangalore, the WIPRO 3D Program Director, thank you very much for joining us.
Thank you.
Have you. Thank you very much. Let me introduce our panel as I have just done with Dr. Chandra. We have Air Vice Marshal ARVINDA AGRAWAL. He is in Delhi also. AVM ARVINDA, thank you very much for joining us.
Thank you, Chris.
Very good. Dr. SHIBU John from 3D Printing and Trinity Media, they're also in Mumbai. We understand it's raining in Mumbai. Thank you very much for joining us, Dr. John. And I beg your pardon, we've got him on mute. He's Dr. John's under family conditions at the moment. And also we've got BHARAT MALKANI also in Mumbai. So BHARAT and SHIBU are both under raining conditions. Thank you very much, gents, for joining us. Let me just check. SHIBU, you're off mute. Thank you very much for joining us.
Thank you so much, Chris, and
guys.
thanks for the panel. Good morning.
Thank you.
Everybody.
So the format for today is, let me just go through some news and updates as we do week to week, and then we'll hear from our panel. We're going to hear a presentation from Dr. Chandra, and then we'll hear a presentation from Dr. John, and then we'll run a panel session looking at 3D printing. It's a big space, and I've kept it broad as well in terms of applications and advancements. But as per our domain, we'll obviously be looking in the security and defence realms for that. In terms of the news of the day, well, I suppose quick follow-up from last week, episode number 6, technical auditing standards, where we looked at cybersecurity, IoT, smart cities and infrastructure. Very good panel session there between India, Malaysia and Australia, now available on our YouTube channel. And a quick wrap up of, we have actually made it. We made it past episode 6 into episode 7, and we'll be making it through to episode 8 next week to the India's National Day, as we set out to do. So well done. But again, the playlist is available on My Security TV. Some market trends during the week, and I thought since we had Dr. Chandra on, some WIPRO news. This is coming out. I had 2 announcements from WIPRO this particular week. One is WIPRO reopening hiring in US and India with an ambitious cloud and AI take. You've now got 3,146 jobs as of June 2020. That's a leap of 741 on the previous month. So WIPRO is hiring again. And the other one is WIPRO selecting Google Cloud to advance its digital transformation strategy. And I don't know if we're going to touch on that today, but as it happens, I just interviewed the head of security for Google Cloud there in Singapore for the Asia Pacific region. So that is episode 211 on the Cybersecurity Weekly podcast. And I think, yeah, we've embedded it there as well. So worth having a look at. Public cloud environments, very interesting domain. Something else that happened during the week was the OSMIN talks at the US Embassy and the consulates between Australia and the United States. And the Secretary of State Mike Pompeo and Secretary of Defence Mark Hesper hosted our Minister for Foreign Affairs Maurice Payne and Minister for Defence Linda Reynolds just last week. And something worth looking at was the joint statement on Australia and US ministerial consultations. Like I said, it sets out the Indo-Pacific recovery, the Indo-Pacific security, regional coordination there, particularly with the US, Australia, Japan and India in terms of the Quad So again, the dialogues there are continuing. Then it covers off on Indo-Pacific prosperity and then a bilateral defence cooperation. It's a classified document, but it's a statement of principles on the alliance of defence cooperation and force posture priorities in the Indo-Pacific, and that obviously follows on the Australian Force Posture Review 2020. So as we've been following on, I think this is our second or third week, we've been following key statements out of the US, particularly Secretary of State. Very interesting reading. Back to some more technology, there's some Canalys updates on the worldwide tablet vendors and increasing shipments on PCs, and cloud infrastructure is also increasing. So we're seeing this advancements in digital transformation, and obviously the cloud and public cloud infrastructure will be driving that. Spending is up by 31% to approaching $35 billion, and that's one of the highest quarters they have seen. So Q2 2020 cloud infrastructure services market on the increase. Top four providers are around 63%. So we've got Alibaba, Google, Microsoft Azure, and AWS. Quick plug to AWS. We're running a on-demand series, a sponsored on-demand series on AWS. So if you're looking at AWS platforms from a security context, welcome to have a look at our newsletters, and you'll see the on-demand links in there as well. Now twice a year, the Office of the Australian Information Commissioner, we have a notifiable data breach legislation, and they produce this report. It used to be quarterly, now it's biannually, just on the key notifications. So any company being breached in Australia now has to notify the market, and we're seeing overall notifications are down just under 3%. Malicious attacks has been the cause of these breaches, are down by about 7% on the previous 6 months. Human error continues to be the highest cause of data breaches here in Australia, up by 7%, and system faults also down by 7%. So the technical advances are driving down the causes of data breaches, and the human error is there as the main. And just Raman, thank you for sending me this today. This is the Draft Defence Production and Export Promotion Policy, the DPE PP 2020, which sets out some key goals and objectives. I believe we've put this on the Asia Pacific Security Magazine website today as well in terms of a link, but it's really looking to achieve a US $25 billion turnover and an export of $5 billion in aerospace and defence goods and services by 2025. So sounds pretty ambitious. Ramon, have you got any initial thoughts on this one that you'd like to raise?
No, the draft document is released 2 days back, and by 17th of August, industry is supposed to give the feedback and suggestions on how to do it. And our association, along with our partner leadership, would like to work out. And today, since we are doing this 3D printing webinar, we would like to have some of the suggestions invited from the panelists also, how India takes the chunk of the export market by way of 3D printing in addition to other opportunities itself. Thank you.
Yep. The full announcement is on the Asia Pacific Security Magazine, and I think I just cut that off at the bottom there just to get it on the slide. But yeah, pretty ambitious and well worth a look at right in our domain of aerospace and defence. Just some updates on the marketplace in terms of key reports coming out. I mentioned the notifiable data breach report and some other reports. This is an interesting one from ESET. The ESET threat report for Q2 2020 is also worthwhile. And if you're following ESET, we've got the ESET training on the marketplace as well. So that's a wrap up of the news of the day and of the week since our last episode. We're going to hear from the panel. Dr. Chandra, you're okay to give a presentation? I've got your slides with me. And yep, okay. So just for the audience, they should know by now. I'm just going to skim on this in terms of our series subject matter. We had 3D printing right in the middle there, and it's good to be finally covering it. We've touched on it briefly. It has come up previously, I think in episode 2 or 3, in terms of the Australian Defence Force using 3D printing technology in the field. And so, yeah, it's come up, so it's good to have a good deep dive. And we're very privileged to have Dr. Chandra with us, the WIPRO, beg your pardon, 3D program director there. And I understand you're in Bangalore, Dr. Chandra.
The presentation. Okay,
Yes,
thanks a lot.
please do.
Thanks for the kind introduction. The interest in the world of additive manufacturing has been continuously on the upsurge for past few years. And if you do objective analysis of some of the factors that are contributing to this particular upsurge, you can easily make out what are these growth factors due to and what is the reason behind this particular hype. So in just next about 10 to 12 minutes, I'm going to encapsulate the applications of additive manufacturing, to be very specific, metal additive manufacturing in the design and manufacturing context of defense and automotive or aeronautical companies, both in the national context as well as a global context, as experienced by WIPRO 3D. Fundamentally, the additive manufacturing in the current shape is no longer just confined to manufacturing context. It's become an interplay of design, material science, laser physics, control systems, advancements of simulation and software engineering. And because of all these versatile contributions, you can easily see continuous improvement in the kind of applications associated with both prototyping as well as a batch production and series production in a wide array of sectors, ranging from aeronautics on one end of the spectrum to naval and marine systems at the other end. And this particular phenomena is also augmented by wide repertoire of materials, including plastics, composites, bimetals, metals, so on and so forth. So the 10-minute presentation that I'm going to make today is going to only focus on application of metal additive manufacturing for aerospace and defense. One discernible factor which has come to the forefront in the recent times is this technology has undergone a tremendous metamorphosis. No longer it's a prototyping tool or a design visualization enabler. It has become a very powerful an option for realization of the end-use functional systems. And what is the key trend, or what are those key functional factors that are driving the industrialization of AM? There are multitudinous factors, but I would like to concentrate on 3 to 4 of them. The first and foremost is about increasing the efficiency. So if you take a costly material of like titanium 64 or Inconel 718, if you were to employ those conventional manufacturing techniques, the buy-to-fly ratio, which is associated with that kind of a system, pales into insignificance when you compare with a similar parameter for additive manufacturing. The next one is about improved or enhanced designer confidence. There are a lot of agencies today which have got captive data on the material properties, both at the room temperature as well as high temperature characteristics of nickel alloys, titanium alloys, steels, etc., etc. With this kind of a database being made available to the designers, they're able to think about introducing new paradigms based on design for additive manufacturing. Last but not the least is about increasing regulatory acceptance, whether you're talking about airworthiness authorities or certification authorities in India or abroad. There is a rigor among these agencies in terms of accepting additive manufacturing as an alternate to the conventional manufacturing, even in case of critical components like fuel nozzles and combustors and turbine blades, nozzle gateways, so on and so forth. Augmenting the story is also the material choice. Whether you're talking about high temperature alloys like Inconels, Haynes, Haste alloys, or lightweight materials like aluminum alloys, ALSI 10mg among the most widely used ones, or high strength, high ductility materials like titaniums, and very hard to machine materials like tungsten and tantalum. Additive manufacturing today in the current context can offer solutions. Okay. Thanks a lot. Sorry about the technical glitch. As I was explaining to you, there are several trends which are responsible for enhanced industrialization of metal additive manufacturing. The most important one is the enhanced designer confidence, which is supported by the captive production, captive effort of material properties, both at room temperature and high temperature. And one of the important trends which is seen both in the national and global context is increasing regulatory acceptance for the additive manufactured parts. It does indeed entail special effort on the part of the certification agencies, to think about protocols through which additive manufactured parts can be tested, can be certified, and the efforts are on. Now, what is very important is these efforts are ably supported by the material choices. If you're talking about high temperature applications corresponding to turbines, combustors, exhaust nozzles, you have a wide variety of nickel-based superalloys, the most popular being the Inco 7 Manite. If you're talking about high strength applications, we have got titanium and allied alloys. And if you're talking about low weight applications, we have got plethora of choices connected with aluminum alloys, the foremost being ALSI 10Mg. The most important aspect is there is an effort on the part of especially the powder metallurgy industry to develop new material combinations to take advantage of additive manufacturing. Just to give an example, there is a material called scam alloy, which is an ingenious combination of the strength, microstructure, as well as the ductility that almost mirrors titanium, but it comes at the weight of aluminum. We have a wide variety of the technology options too. We have got powder bed options, which manifest in terms of laser-enabled powder bed option and electron beam melted option. These are the technologies in which WIPRO 3D has been doing directly the work. And we have got directed energy deposition options and other options. But when it comes to the choice, you need to think about several functional parameters, including the complexity of the features that they need to be realized, what is the availability of the material, what kind of post-processing that needs to be in place, the deposition rates which are concomitant to this particular process. So if you consider all these things, there are some natural winners there, like powder bed technology and blown powder technology. There are other technologies which are slowly catching up. Now I'm going to talk about, in just next to 7 to 8 minutes, I'll talk about some of the applications wherein we had an ability to provide value to the customer by taking advantage of additive manufacturing as a substitute for conventional manufacturing route. Contributed to continuous uptake in the market for both the metal technologies as well as non-metal technologies. As per one of the recent reports, you can see the world of additive manufacturing, or the business of additive manufacturing, is more than $11 billion in terms of its value. Nearly 35% of this particular business is driven by metal additive manufacturing. Now, what are the challenges which are associated with the technology? See, fundamentally, the entire focus is on the technology, but there is also a lot of requirement in terms of controlling the parameters. The parameters could be with reference to the input data, or with reference to the metal powders, or the machine-related parameters, because reuse is important segment of this particular aspect. So how exactly you maintain quality when you are reusing the parts? And of course, the build parameters which are corresponding to the production. Just I'll pick up one example to amplify my statement. The fundamental parameter connected with the laser beam in additive manufacturing system is the scanning velocity. And the other parameter is the laser power. You can play around with these parameters, but if you are not judicious, you end up with either non-fused powder, or due to excessive infusion of the energy, it may lead to keyholes, or if you use too much of power and too high a velocity, it may even give rise to balling defects. So it just proves the point that it's just not about the technology, it's about controlling the defects. It is about controlling the micro, macro, as well as atomic level manifestations through optimization of the process parameters. So at WIPRO, we don't just focus on the technology, we talk about the design aspect, we talk about materials being adapted to a specific situation. We talk about post-processing, because post-processing contributes to nearly 25 to 30% of the process cost. So even if you were to realize the part, if you spend too much of time on the post-processing, the economy of entire intervention is distorted. And last but not the least, it's about customization of the parameter development. In the recent times, we have seen the emergence of many consultants, new organizations which are focusing on the part substitution. Incidentally, their focus just is confined to only technology and application of the build parameters. But unless you sensitize the customer to the limitations associated to the entire process chain, encompassing the input data to build parameters, to post-processing, to certification and qualification, he is going to be very disgruntled customer in course of time. I would like to conclude my presentation just by picking up one of the characteristics of the aeronautical or aerospace applications. Even in case of seasoned users like Saffron, like GE, like Onera, we have seen that our MTU, to start with, the focus is on introducing additive manufacturing as an alternate to the conventional manufacturing for parts wherein the structural margins are reasonably high and the consequence of failure is significantly low. As you start building your proficiency, as you start understanding the laser particle interaction, as you are able to develop the parameters which are able to ensure the combination of strength, ductility, and integrity, you slowly move up the process chain. And in the current context of additive manufacturing in the defense sector, we can see a plethora of applications wherein this technology is being used for the parts wherein structural margins are low and the consequence of failure is very high. So WIPRO has been focusing on several value aspects connected with the usage of additive manufacturing in the context of defense and aerospace. I would just like to pick up three important things and then conclude my presentation. The first one is about improving the functional performance. We can do any number of design iterations without the cost and time penalty by virtue of integrating additive manufacturing into the design cycle. And this gives tremendous amount of latitude to the designers in terms of incorporating multiple functionalities into a single part. So you can look at a part which can ensure necessary strength, necessary endurance, necessary hardness that can be controlled in a spatial manner by using additive manufacturing as a tool for design. The second one, which is paramount to the aerospace sector, is the weight reduction. Weight reduction can be achieved through part consolidation, or weight reduction can also be achieved through topology optimization, wherein you remove the material from those zones which are not subjected to high amount of loading and make the part leaner and more efficient. And fundamentally, this particular thing may also lead to organic shapes or bionic shapes. And when you're using metal additive manufacturing, the advantage is, since it is devoid of the usage of the tooling, you can chase the imperatives connected with the weight reduction without the restrictions imposed by the conventional manufacturing and tooling. And last but not the least is the supply chain. We have seen in India so many efforts in the recent times wherein they are looking at the legacy parts that have come from different origins, including the French origin, Russian origin, and other countries. And in some of these instances, the access to original drawings is limited. In some of these instances, the tooling may not be available. But because of the fact that today we are able to synergistically combine 3D scanning along with the additive manufacturing, we are able to create new paradigms in supply chain in terms of producing the spare parts, even in case of legacy systems, within a short span of time. So I just want to conclude my talk by saying that additive manufacturing as a technology has given freedom to the design groups in terms of reimagining the designs, and it also has given a space to the manufacturing context in terms of doing batch production or series production without the tooling penalties that are associated with conventional manufacturing. And aiding the scenario is the availability of high strength, high performance materials. So a combination of the technologies and materials and design context is enabling in terms of enhancing the footprint of the technology in aerospace and defense context. So with this, I would like to conclude my presentation, and I would like to say a big thanks to the organizers as well as the attendees. Thank you so much.
Thank you very much, Dr. Chandra. That was a fascinating presentation, and I can see why Raman was so keen to get you on as well and cover 3D printing. I'm conscious of time because if we even start asking you questions, we're going to literally take up the hour. Can you please stay on with us? And I'm going to hand over to Dr. John and have him present his presentation, and then we'll run that panel afterwards because well, I've got copious notes here as well, but you've really covered off the key aspects there. So what I'm going to do is I'm going to hand over to Dr. John now. And that's coming over to you, Shibu.
Chris, before Shibu's slides come on, I have got a burning question for Dr. Chandra,
Yes,
which you
please.
can answer. Dr. Chandra, one of the early days of my engineering, I studied superconductivity. But after that, we never saw any superconductors coming to the marketplace. Now, with the breakthrough of WIPRO into the 3D printing, I would like to know, may not be in today's session, somewhere separately, the 3D printing vis-a-vis the superconductivity, what is the future?
Yeah,
We can
sure.
discuss after the.
Yeah, we will discuss, sure, in future.
Shibu, I don't know if that's working for you. I've got your slides here. You want me to go to your slides here? And you're on mute. Hang on. Sorry, Shibu. I'm going to go to your slides.
Sure. Thank you. Thanks, Chris.
And that should be working. 1 second. Can you see that?
Yes, I can.
Just nod your head if you're, or just let me know when you want me to move forward.
Yeah.
Thank you very much.
Yeah. So, gentlemen, thank you, and thanks, Chris, for this wonderful opportunity, and thank you, Mr. Ravan Sorupi, for organizing a wonderful meet. I think 3D printing is a technology which aerospace is actually gaining a lot of traction, and with time, and we've seen with the presentation made by Dr. Chandra, I think it was very detailed. My presentation would actually give a sum up of the technology which is actually been taken now seriously. It was then also for the last 8 to 10 years, but now just giving a overall view in terms of how the technology has benefited the aerospace industry. Yeah, so we can go to the slide, the first slide. Okay, so introduction and history of 3D printing, aerospace and defense. The aerospace and the aviation industry is set to gain a lot of rapid growth with this technology. We've seen that the aviation market has been expanding for the last every year. 18% has been the traction in terms of growth. The adoption of 3D printing technology has shown immense growth in the Indian market, which I did mention as recently. That we've also seen WIPRO infrastructure, that Dr. Chandra has been a key respondent to also have gained the first initiative of having 3D printed metal components, working very closely with ISRO. And we've also seen that lately, where there are many indigenous manufacturing companies in metal who have really set up their units in India. So that's a good sign for the Indian companies. And I had an opportunity to discuss with Ramanji also about the same, in terms of how the opportunity can be worked out as an association going forward with the senior stalwarts from various key associations working together. Now, what we see is 3D printing technology is expected to change the industrial production scenario, and that is we've already seen the space that we have been able to gain traction with Indian aircraft industry, coming up with various IAI, coming up with various initiatives in this space. Yeah, we'll go to the second slide. Yeah, so Hindustan Aeronautical, that HAL has been a key procurers of this technology, may it be concept design or even in terms of the technology. And again, we've seen WIPRO 3D being one of the leaders in terms of being actively pursuing the space with HAL, in terms of also setting up their R&D centers with HAL going forward. And we see other companies like Airbus, GE, Stratasys, Boeing, all of these companies also looking at India as a good opportune market with 3D printing, because what we see is we have engineers of exceptionally good talent, and it's just a matter of education and sharing knowledge with these using the resources through educational institutions going forward. So we as an association also, 3D Printing Education and Research Education Association, is working very closely with industry bodies and government to ensure that how education and research can be the key going forward, in terms of instituting this with colleges and engineering colleges, and that's been our conscious effort. So it's a good start to begin with now, but we're seeing that the traction is gaining overall with the technology getting its prominence in the country. Yeah. Yeah, the next, Chris. Yeah.
Cool.
Yeah. So yeah, you skipped the other one. That's okay, as long as we have.
Sorry.
Yeah. So yeah, that's perfectly fine. So
A bit of delay.
yeah. So the overall market that we see, as per AMA research, the Indian aerospace market is estimated to reach USD 3 billion by the year 2020. Unlike if it's not really affected by the COVID, the present state, but otherwise that's been the traction that we've seen in terms of growth. 3D printing in aerospace industry, which is contributing, is close to USD 220 million. And that's a phenomenal growth to begin with, a technology like 3D printing being a key factor for growth in the aerospace industry. And as Mr. Ramanji also mentioned, that is there a possibility for exports from India to other countries? Yeah, I think it all would be a key aspect in terms of working as a cohesive consortium, working with associations like AD, CAI, and various other bodies, and also associations that we've been able to set up, and industry and the companies going forward. And I think there's a great opportunity going forward. Yeah. So Chris, if you don't mind, yeah, the next slide. Thank you. So there are opinion leaders who have been able to share some of their opinions on this. HAL makes use of direct metal centering techniques to print components for indigenous developed Hindustan turbofan engines 225, and they've been doing it, and they've also been able to justify in terms of comparing it with CNC machining. So I think overall there are instances and opinions coming from industry leaders about how this technology can really be a technology which can be really consumed. But that all comes to a point where accreditation, validation will also be the key, and I think companies are looking forward to that kind of a process of certification also going forward. So I think it's going to be step by step reaching to the final destination, but I think we have an immense potential going forward. Yeah, Chris. So the Indian 3D printing marketing aerospace outlook, when I'm currently, most of them have been modeling for sure, testing and prototyping, but the potential application has also been seriously looking at lightweight components and high strength materials. So I think everything is to do with material science. So with material science and design for additive manufacturing, which is the new norm, what we see is when design, the entire the formulation will be different from the current way of designing. So it is very specific to looking at the final solution in innovation and materials. So design for manufacturing is the new norm, and that too is going to be a very, very important aspect for us, starting from educational, with engineering colleges. Getting this should be a part of their curriculum, I'm sure, because that's how the future aspirants will get to know that this technology is here and they have a potential going forward. So, but coming to the service and the business aspects, business component for defense has been the current application. Replacement parts has been normally been used. A printing part with minimal wastage, production of satellite components. So these all are, in a satellite, there's so many components that you need to have. So here with 3D printing, it can be well designed with what is expected through design for manufacturing, and then you can have one consolidated part to be printed to then ensure that you don't need too many molds to be made, and it will be, again, cost. There's a reduction in cost, and it is also making things more simplified and faster and efficient. to get the final outcome of the product. So key takeaways again is 3D printing has proven to be extremely beneficial in aerospace industry. 3D printers allow experiencing with lighter, sturdy, plain parts that reduces fuel cost. High-end 3D printers are also will also allow printing of complex parts. NASA has already successfully tested 3D printed parts for its satellite, as Dr. Chandrasekhar did mention about the examples for what it can be used for, and also what we see is key people like Prakash Panesarabalam, titled Additive Manufacturing, Aerospace and Defense Sector Strategies of India, Hindustan Aeronautics, is the only aircraft manufacturer in India using AM technology. So we have the epitome of India, HAL, also using 3D printing technology in their course, and we see that there's a prospect going forward. The next slide.
Dr. John, I'm just conscious of the time. I'm sorry, but
so we will just run it out. We'll just run this through. I think this is all introducing the companies who have started. So WIPRO 3D, as mentioned, Intech, DMLS. These are the companies who have started in India and they've set their base. And it seems that they are all looking at gaining the traction going forward with additive manufacturing in aerospace.
Can I ask?
We'll go to the next slide.
I was going to say, is there a particular place in India that is being touted as the key location for 3D printing, advanced manufacturing? How many cities in India are sort of being touted for that?
Yeah, so Bangalore has been a city, a tech city, wherein there are maximum number of companies who they're manufacturing these machines now, including WIPRO 3D, who's done their bit, a good initiative with EBM technology. If I'm not, and then also the other companies who have actually set up their base in Bangalore. But there are many 3D printing service providers in the country. There are many hubs in the country who are actually providing these services. They have bought the machines and they've actually offering services in this space.
Right.
So we can just, I think these are all introductions, so I think we can stick on the time. Yeah.
Okay.
So I think there could be more questions.
Let's keep this slide up for now. And Raman, would you like to coordinate the panel if you may, and open it up to the panel in terms of the key areas you want to discuss?
Yes.
Yeah.
Thank you, Dr. John.
2-3 points which I would like to share is that the Indian government has reduced the duty on MRO GST from 18% to 5%. Bharat, kindly correct me if I'm wrong. Dr. Chandra, what is the GST on the 3D printing parts? Is it 18%?
Yeah, it still continues at 18%.
So we are going to present a document to the Government of India, Ministry of Defense and other ministries also, because 3D printing is not only for the aerospace itself, it is also used for medical implants also, many things itself. Even the sports industry is using it. We would like to recommend to the government to reduce the GST from 18 to 5%. It will add to the further, impetus on the sport itself. The second issue I've got is on the, the manpower required for the 3D printing itself. And in case the 5 clusters in India, both in the North Defense Corridor and Southern Defense Corridor, there are about 15 odd cities which are going to be clusters for the Defense Corridor itself. We have got other requirements for the medical industry, the dental industry, the sports industry, and many other industries itself. In fact, the garment industry, the jewelry export. There's a whole lot of ecosystem which is evolving in India now. And I'm sure that we would like to have a separate full-day session on the 3D printing itself. Dr. Chandra, for you, I had 2-3 questions. One was on the superconductivity of this. Secondly, I have got a very nice application. When it comes to the airborne applications, I could have the very small black box, in which the transmitter receiver is on the same box with size. So what are the views? Where do we see the reduction of the size into space application itself? After Dr. Chandra replies, I would like
reduction of this.
Arvind Agrawal and Bharat Malkani to follow after this. Over to Dr. Chandra.
Yeah, quick reply. Yeah, the reduction in weight is possible provided you re-engineer the part. You can say reimagine the design. And this reimagining of the design comes from several aspects. A, complete insight into the material performance characteristics at the envisaged operational conditions. The second one is about the technology that you're using. For example, if you're using the DED technology, it produces only near net shape parts. But if you use laser powder bed fusion, you can get very precise feature definition. So this is one more important functionality that comes to the forefront. And last but not the least is, if you think that separate parts can be consolidated into a single part, then it directly contributes to the obviating of the fasteners, which in turn contributes to lightweighting. So important thing is additive manufacturing has to be. Yeah, you want me on camera because the wavelength was. I'm sorry. I'll just try switching on. Okay. The important thing is it's just not to look at additive manufacturing as a tool in isolation, but to look at it as a synergistic tool in tandem with the design practice. Then only we'll be able to do the lightweighting.
Thank you.
Can I just jump in with a question there in terms of, I've seen very interesting designs. You mentioned reimagine the design. How much, and we heard from a startup last week, VMTL, using virtual reality, mixed reality designs as well. How much of mixed reality design, 3D design, and artificial intelligence, allowing a machine to redesign fundamental designs, how much of that work is going on?
Should I answer that? Can I?
Yeah.
Yeah. Okay. I think Airbus has been at the forefront in terms of producing digital twins for some of their projects. And as you rightly mentioned, when you create digital twins, and when the digital twin is available to you, you can do these design iterations in real time and get the feedback from the system level. So the reimagining of the designs is going to be order of the day in course of time, because of the fact that the systems need to be built both for strength and endurance. And when you are able to get the real-time data through digital twins, you can look at more and more applications wherein the parts are taking different shapes or different avatars by taking advantage of the available technologies.
Very good. ARVINDA.
Okay, thank you, Chris. Good morning, everybody. We just heard two very nice presentations by Dr. Chandrasekhar and SHIBU John, presenting us the future of AM technology. Actually, we should stop calling it 3D printing, by my view, and start calling it additive manufacturing, because 3D printing somehow does not look too professional for use in aviation. And frankly, what is the difference? Nothing. In a traditional manufacturing, we use a 3D CAD model to remove material and produce the item. Whereas in additive manufacturing, we use a similar 3D CAD model to build the part layer by layer instead of removing. I have personally spent a lot of time, 37 odd years in the Indian Air Force, and now for last 17 years in the industry. So I think I can present to you what is the future outlook for us from both sides. So I'll put it in very simple language. The present scenario, as in India, Mr. SHIBU John has just now shown us slides, number of items by HAL, engine division, etc., etc. But as far as I am aware, only one additive manufactured part, that is the fuel system elbow for Sukhoi 30, has been approved by SAMILAC till date for actual use. In fact, there was a big ceremony at Aero India 2019 for handing over the approval for this particular item to HAL by SAMILAC. I just happen to be present there, so I know it. The Indian Air Force has not yet made up its mind about how to go about using this technology to its advantage. Raman just now informed us that they have issued a RFP for some 140 odd points, but I am not too sure what they are going to do about it. What are the prospects of the 3D or additive manufacturing? What are the typical attributes of a military aviation supply chain? These are manufacturer-specific adaptation, long life cycle, extremely high safety requirements, very small batch size, very high levels of thermal or mechanical loading, especially during operational takeoffs and landings. Anybody, whether traditional or additive manufacturer, these issues have to be accounted for whenever we want to use it for military aviation. Let us look at some of the obvious advantages for the military aviation using additive manufacturing. Firstly, on-demand printing of spare parts. This reduces the cost of inventory both for the user as well as for the supplier. We can use the concept of buy as you fly. But lead time can be reduced almost by an order of magnitude using additive manufacturing. In a war scenario, ability to produce your own required part, of course, has advantages which are difficult to quantify. Additive manufacturing can also bring down the cost as well as the weight of the parts. We have the ability to produce complex shapes and geometries and parts with internal stress structures to reduce its weight. It is possible to reduce weight in some parts to almost half. This is an obvious advantage in aviation, not only military, but also civil aviation. Next issue in aviation is long life cycle of the system, which often leads to obsolescence of spare parts. In India, we have military aircraft which are flying for 40 years or more. In such cases, the OEMs are not able or willing to supply the replacement parts. Additive manufacturing offers us a simple solution to get such parts. Incidentally, the United States Air Force has set up a rapid sustainment office at their Wright-Patterson base in Ohio. That was only last year, December 2019. As per them, 50% of their Air Force supply chain is provided by a single source or by no source at all. And they look at the additive manufacturing as a way to provide a new source. USAF is already using over 2,000 additive manufactured parts. Maybe all other air forces start to think about it. But like everything else, when you want to use a new technology, it has its own problem area. Firstly, it's material. In spite of looking at long lists presented just now in the two earlier presentations, at present, additive manufacturing uses a very small group of polymer and metal powder. And they can also be used only in a limited number of areas. These materials are also a little more expensive than normal materials. Also, to be truly flourishing, additive manufacture would require systems that can manufacture parts with multiple materials simultaneously. This is the case with very few AM systems today. Most of them use a single material, in each manufacturing line. At least I am not aware of very many systems which can manufacture multiple materials, single part. Material properties is an additional concern. They are different. AM material properties are obviously different from what are available in the bulk material. They also change during the build-up of the part. Therefore, satisfying original requirements of the structural integrity is not very simple. Next is additive manufacturing, inability to manufacture large parts, which is a serious limitation. But I, however, understand that BAE has recently managed to manufacture a 1.2 meters part in titanium using additive manufacturing. If this trend continues, then probably this may not be a serious limitation. There are some concerns about getting quality consistency, especially for the fully dense metal parts. The strength in the plane of layers is not uniform. I think this was brought out by Dr. Chandrasekhar in his presentation. It may be possible to deal with this problem with a computer-aided 100% inspection during manufacturing process itself. However, at the moment, it remains a problem because such inspection processes are yet under development. Repeatability and tolerance are the next problem. At the moment, we are able to get tolerances of 30 to 40 microns in additive manufacturing. In aerospace, tolerances of 10 microns are what are expected. That means some rework of the parts produced by additive manufacturing may be required. That, of course, adds to your infrastructure and costs. The issue of high cost of materials has been brought out by the earlier two speakers. So I will, to my mind, another very serious issue is certification. As I mentioned, till now, CEMILAC has only certified one part for aviation use in India. And everything that we produce requires an airworthiness certificate. So we need to develop a level of confidence that the part we produce with our additive manufacturing is the part we need. Maybe we can look at the possibility of some accelerated certification for non-critical parts. But this is an area which we need to discuss with CEMILAC in serious. Last but not the least, problem area is cybersecurity. Of course, I don't want to get into Chris's area of specialty, but to my mind, large organizations, let's say Indian Air Force, would need to use a number of 3D printers at diverse locations to take the advantage of their capabilities and capacity. This means they are all to be connected on a net, which is a serious cybersecurity issue which has to be handled, especially for the defense requirement. Having mentioned a large number of problem areas, I would also like to add a comment that whichever way we look, there is no doubt that additive manufacturing is the future of manufacturing technology. It may not be a substitute immediately for traditional manufacturing technologies, but it is definitely a complementary process. It is expected that the aviation market, additive manufacturing worldwide, may grow to over $3 billion in the next 2 years. I think SHIBU said that in India itself, we are looking at some $220 million. But if we look at the worldwide picture of $3 billion in next 2 years, I think we can do probably better than that. For Indian Air Force, maybe a good starting point would be for all our base repair depots to start using additive manufacturing for replacement of non-critical parts for airborne application. This is a simpler matter because for non-critical parts, even for airborne parts, we do not always have to take SAMILEC certification. Indian Air Force has its own system of certification. I am only suggesting, since I am outside now, that maybe we can start thinking about it. Also, we can always use additive manufacturing for parts which the OEMs are not willing to supply. And there are large number of cases for the armed forces for that. So there we can, from there on, we can graduate to technology for most of our requirements in MRO field at least. Indian Air Force also uses a large number of ground-based systems. These may be radars, communication systems, and ground support systems for the aircraft. Use of additive manufacturing for these areas or replacement parts for these areas is a much simpler issue, and probably we can start looking at these issues. I think with these I have brought out a few points that I wanted to talk about future use of AM by the defense aviation in India. Thank you very much.
Can we have Mr. Bharat on the line, please?
Very much,
Yes.
Raman sir.
Yeah.
Thank you, Air Marshal. That was very good. You have covered a substantial points. I have a few questions here for Dr. Chandrasekhar and Shibu John. Dr. Chandrasekhar, let me start with a little bit of introduction. I am Bharat. I represent a company called Max Aerospace. We are India's leading MRO, one of the only ones with both FAA and EASA certification apart from DGCA. Since we have a large amount of parts consumption as an MRO, we have something called PMA, that is a Parts Manufactured Association, a part not manufactured by the OEM but certified by the regulatory agency. An additive part, if it were to be applied, additive manufactured part, if it would be put on an aircraft, would necessarily need an FAA or an EASA release certification. I don't think we have yet managed to touch upon this aspect, and I don't expect you to have an answer, but this is going to have to be the way forward when your organization or Shibu's organization works with the big boys, be it the Collins or the Lockheeds or whatever, that they should be willing to give us what is known as a no technical objection, without which even if a part is made identical or even better than the OEM, it cannot be used. So this is something for you to mull over. But in order to get to that part, we have to do something called as MSDS, the material breakdown. How are you proposing, if I take a panel from, say, a Boeing aircraft or an Airbus, which I'm confident, or a piece of metal, that it can be manufactured additively, who is guaranteeing the MSDS of the additive product that I'm going to use? Can someone guide me on this first?
Does anyone want to take that question? Maybe
Dr.
Dr.
Chandra or Shibu, how are you? Let me repeat. If I have a material that I want to use for MRO as a replacement part, how do we do the MSDS proving, concurrent proving of the original part with the additive part? It could be better, it could be worse. That's not the issue. How do we prove equivalency?
Yeah. Can I just answer that?
Please, sir.
Yeah. Okay. See, fundamentally, if you're looking at legacy parts, imagine a part which was manufactured 30 years ago. The kind of access at that point of time OEMs had to manufacturing processes were completely different. A part which was manufactured originally using forging and machining or welding and machining, today can be completely relooked in a different way. So as you rightly mentioned, we are not looking at part substitution in isolation. we are looking at replicating the performance in such a way that it can be commensurate with the expectations of certification authorities. As one of the preceding speakers mentioned, till now the certification by CEMILAC has happened only for one component for this very precise reason. The reason is, if you have a design manual, if you clearly know to what levels should the component be tested with reference to endurance, with reference to temperature resistance capability, with reference to fatigue capability, then the test becomes easy. But in case of legacy parts, the biggest challenge is the current user is not the designer of the parts. So even if CEMILAC were to ask him, or even if a service provider like us approaches the user, he will say, I have got only access to the part. I know nothing about the design context. You recreate the design context, you specify the manual, and you test it, and finally we'll approve. So this is a big quagmire of situations in terms of uncertainty. That's why in most of the situations now, including NASA, the evolution has already happened only with parts which are in the secondary path or tertiary path, where the risk of failure is minimal. When you are slowly moving towards high risk, you would like to have a big material properties. I would like to mention the much touted fuel nozzle example of GE. I'm sure they should have done thousands of parts, including fatigue parts, creep testing parts, and tensile testing parts. They are called witness coupons. These coupons are built alongside of the part on the machine, and they are subjected to exactly similar conditions as the actual parts. So the confidence to replace a part, the confidence to comply with the requirements of the certification authorities only comes from through two channels. One, by creating a respectable size of captive repository of material properties at all the envisaged operational conditions. Second one is successfully taking the additive manufacturing part, putting into the test rig, and testing up to the endurance expected by the group. I think only when you can combine these two requirements, somebody will take the risk of substituting the originally or conventionally manufactured part with additive manufactured part. And just to augment whatever statement I made, we are working today with HAL helicopter department for substituting a part which was traditionally forged and machined out of steel with an additive manufactured part. And while the part was manufactured within 2 months, we have spent more than 14 months in testing.
So, Doctor, thank you so much for that clarification. Very clear. This is typical 2 months manufacture, 14 months testing. As I understand it today, therefore, unless we do not have a genuine ecosystem for the domestic aviation industry, there is no way I see the ability of the MRO industry to genuinely take these additive parts and put it on existing aircraft, what you would call legacy aircraft, and for clear reasons. Now, taking it ahead from there, we have been looking at a domestic aircraft industry, and the only aircraft industry we have is HAL. HAL is someone that you guys are already working with in some form or the other. To go a little further for you, Ramanji, when you mention GST and customs, as an association, our first primary issue should be customs duty. Remember, GST is a pass-through revenue or a cost. So even the final user may not necessarily be impacted by a cost of GST, because you are really charging it in the end to the end customer, which in this case would become the public. But the customs duty is a cost that will increase an already expensive product, therefore increasing your capex, which is uncalled for at this point of time. GST and capex have to be attended differently, different councils. One more question for you, Shibu. When you replace a part, now let's assume non-aerospace, because I'm going to park it. You can do a strength testing, and you can do size measurement up to how many microns is it equivalent?
The technical aspects, I think I will leave it to Dr. U. Chandrasekhar to actually share. Yeah, because I come from a media perspective in terms of.
Sorry. So, Doctor, up to how many microns are we able to prove equivalency of an additive manufactured part vis-a-vis a machined part?
Can I quickly answer? On the machine could be on the machine could be to plus or minus 40 microns. But if you do post-processing, you can get parts, as I have shown, we have made the parts for nozzle guide vanes, wherein the surface finish is to the levels of 0.8 micron REA. And the tolerances are within plus or minus 5 microns. So the additive manufactured parts behave like cast parts or forged parts. From the machine, you get certain accuracy and certain surface integrity, but definitely you can improve it substantially by using post-processing techniques.
Thank you. I have no more questions, Ramanji.
Chris, may I ask you a question, please?
Go, Raman, yes.
Yeah, I was just wondering that being an ex-WIPROite, where software as a service became the norm, going forward, if we say tomorrow 3D printing becomes a culture in India, so Dr. Chandrasekhar and Shibu John, I was just wondering if the 3D printing becomes a cottage industry in India, hypothetically, and we hope we will do that. Do you think a scope of third-party independent testing agencies coming into the 3D printing world? That means I produce a part, I don't spend time and effort on testing. Somebody else does it for me and gets it certified. For example, the drone testing, government is now thinking of independent drone testing agencies. They've got their Government of India labs and ecosystem being available to us. What in case tomorrow we have companies in Bangalore, Chennai, or somewhere else producing parts, and the company which is making parts give it to third party for doing only the testing and give the reports? Over to you, Dr. Chandrasekhar.
Sir, it's a very, very interesting observation. I think there is so much of forethought in the comment that you have made. I just met the CE Semilac few weeks ago, and very interestingly, what did he mention is Semilac is in the process of opening up the test facilities of many public establishments, including those of DRDO, for all these purposes, including testing and certification. Your observations on taking up the testing as a third party are absolutely valid. But incidentally, many of the test facilities that are connected with high temperature systems, whether you're talking about space or defense or cryogenic systems like that of rocket engines, they're too costly to be replicated in a third party context. They're so costly that the testing and certification may become prohibitively expensive if somebody were to take it up as a standalone venture. So the viable option would be to think about doing material testing at an elementary level using NABL certified agencies wherever we have got access to, and then look at the advanced testings which require tremendous amount of physical infrastructure in terms of collaborating with the agencies like ISRO or HAL or GTRE or ADA, so on and so forth.
Sir, just an added question on that. Since Government of India has opened the space sector for the private sector also, there are about 10 to 20 agencies already working on the space sector, and more will like to join, including the foreign OEMs wanting to set up joint ventures itself. Right now, I know of at least 10 companies who are doing, and they have their own in-house the ecosystem of testing for aerospace, defense, and space agencies. They have a work not even for the one full shift itself. So just an 8-hour work, there's a spare capacity available. So let us give them this work of doing the third-party testing itself, as and when the government does it. So there is a capacity available. People don't have the job for the defense market itself. Let them do the 3D printing. I know the Halt and Horse facility, which many companies in Chennai or Bangalore have got, and that capacity is available to us, including some facility in WIPRO itself. So I feel this could be explored as part of creating new job and, a separate kind of a business venture itself. Somebody does the only focusing on parts, somebody does only on spare capacity utilization. It will give them the return on investment of people who already have the capacity itself. I know many companies who are having this infrastructure itself, and they are not busy at all today. Yeah, thank you. Doctor,
if I may add here, I think there are large number of independent testing agencies available even today. It's not a question of specific testing agencies for additive manufacturing. a part manufactured by additive or subtractive manufacturing technology, testing technology is not going to change too much.
Absolutely.
And
That's what I'm
we
saying.
have a number of agencies, independent agencies, whose only job is testing. So we can, small industries can definitely entrust to them. But the warning is that the responsibility of getting the part certified will still remain with the person who has produced that part, whether small industry or large industry.
That's right.
So the responsibility will lie with you. Agencies are plenty. If you want, we can share those.
Just to
Okay,
share,
look,
yeah, Chris, last point from me.
Here you
Me
go.
and Dr. John have joined hands together to come out with a all India directory of 3D printing companies in different size shapes. So the work is already on. We will share with the audience, those who are registered with this seminar and the next seminar. And we are going to start rating these companies by way of various, capabilities and competencies itself. Over to Chris.
Very good. And look, just to finish off on that, there are a number of questions here from the audience that we have run out of time for. I'm going to mention the forum after this, but just some questions just for the panelists so they can have a think about it. What percentage of parts are likely to be in 3D printing or tech for aerospace, submarines, biomedical and robotics? I think longer term it'll be near 100% in terms of additive manufacturing. What are the parts OEMs are not supplying, and isn't the requirements more in Indian military of legacy parts? And then the third one, is the third-party testing relevant to new design parts or re-engineered parts for an existing system? Some very good questions there from Commodore Kumar, for those as well. Look, it sounds like we're going to be back to dive into 3D printing again, I would imagine, given the depth of this particular domain. And we're also going to dive into MRO next week, and I've no doubt 3D printing or additive manufacturing, maybe I should call it, will come up also. So look, on that particular note, I'm going to just close off because we've gone over time again, but that's fine. And just one moment. Just to close off, and I'd like to thank our panel, Dr. Chandra, the WIPRO 3D Program Director. Thank you very much for your time. I've actually been to the WIPRO headquarters in Bangalore. Absolute pleasure to have you on. Air Vice Marshal ARVINDA AGRAWAL, Dr. SHIBU John, lovely to meet you from Trinity Media, and Mr. BHARAT MALKANI, the Chairman for Max Aerospace Group. And we look forward to joining you next week as well. Also, just as I walk through the closing slides, I mentioned the forum. There is a forum on the marketplace. I will post those questions, the outstanding questions, and Raman, maybe through the notes we will post some answers or responses to those. I've got copious notes here. I may take the time to type them up in an article as well. A very interesting time. We've run articles and interest points on 3D printing over a period of time. And as AVM mentioned, particularly on the cybersecurity vulnerabilities in that also. Next week, as I mentioned, we have the MRO industry trends. We'll be joined by Rear Admiral Devendra Sudan, AVM ARVINDA AGRAWAL, and again, Mr. BHARAT MALKANI also next week. We're going to run one more week, and then we're going to move and shift and sort of pivot into an Indo-Pacific series just to broaden it out. Still on the same trends, still focused on India, but we're talking about Australia and the ASEAN, but with that Quad and the way that the region is moving, I think a change of scenery to the Indo-Pacific will also be of interest. And just to plug, you've heard it here first, next week we're running a virtual awards night for a top 20 women in cybersecurity in Singapore. There was a similar, from Wiskira down the bottom there, similar Indian women in cybersecurity event as well, and we'll bring that to you also. So closing off, we'll make some edits to this particular episode, and Dr. Chandra will come back to you on that before we release that. But thank you very much for joining us once again for our India Reach series. Our panel and my co-host Raman Sapuri there in Delhi for the Aerospace and Defence Consultants Association of India. Thank you very much for joining us.
Thank you.
Thank you. Thank you. Thank you all.
Thank you. See you next Tuesday.
Thank you.
Thank you, Raman.
Thank you.